Hi and welcome. In this video, I'll show you how to get started with realvirtual 6 for Unity 6, the powerful toolkit for building industrial simulations and setting up virtual commissioning systems. Whether you are developing a digital twin, testing automation logic with real PLCs, or creating a fully interactive factory model, realvirtual I/O brings all the tools together in Unity to bridge the gap between the virtual and the real world. We'll start from scratch, walk through the basic setup, and look into a simple simulation, step by step. Let's dive in and bring your first industrial simulation to life with realvirtual I/O. Before starting with realvirtual, you need to install Unity. So best is to go to the Unity's website on the download page to create a Unity account and to download for your operation system the Unity Hub. The Unity Hub, after installed, is an application where you are able to manage your projects and your Unity installations. So under installs and install editor, you can install different Unity editor versions. For realvirtual 6, you should use Unity 6.0. In any of the versions, best you are installing the latest version if you are starting from scratch of Unity 6. So in this case, this would be the 6.0 .48. I've got on my computer installed Unity 6.47. That's an older version. That's still okay. In the bug fixes, usually you get some bug fixes, but most of the time you don't need to install really latest version. But you should check and change it from time to time. After Unity is installed, and the Unity Hub is there, first thing for installing realvirtual is to install, to open or to create a new Unity project. So I'm creating here a new project. You should take the Universal 3D Core, the Universal Render Pipeline Core template, and my realvirtual tutorial project. And at any location on your computer, you should create your project. After creating a project, you will create here your project, and now you can select here an editor version. So it's automatically created with 6.47 because under the new project, I selected here my editor version. So always select the 6 editor version before creating a new project. And now I'm opening my project. This will take some time because it will install packages and create the full project structure, because a Unity project is at the end a big folder containing everything what you need for your simulation project. So creating the Unity project took some time, but after some time the Unity project will open. Please again check that you used Unity 6 for realvirtual 6, and you've got now here an empty Unity project. So basically, well, if I select here Show in Explorer, you will see that Unity project is a folder with certain files and included folders. So if you need to copy or save your project, you need this full folder, in this case my realvirtual tutorial. But this is still an empty Unity. So nothing in here related to automation or simulation or robotics or virtual commissioning. So into this empty Unity project, you still need to install Real Virtual. For installing Real Virtual, there are multiple possibilities, and it depends if you acquired Real Virtual from ourselves or over the Unity Asset Store. For the Unity Asset Store, you can open it via selecting here Asset Store. And this will get you to the Unity Asset Store. Within the Unity Asset Store, you can find all our solutions by typing in here Real Virtual. And for example, for the starter version, Unity 6, you can install it by selecting here Open in Unity. And by doing this, I need to accept. And I will get the Unity 6 starter version added to my assets in my package manager. And I need to import it now to my project. This will download the full Real Virtual starter package, in that case, into my project. Here, everything is okay, just import. And after some time, I'm getting Real Virtual copied into my project. While Real Virtual is imported into your project, you need to take care that this window will open here and the installation won't finish before you close this window. So please close it. And this is going to finish the installation of Real Virtual into your project. So here it is. And after everything is installed, you should see automatically opening our demonstration cell. So my advice would be first to adjust a little bit the view, because all these gizmo icons are a little bit annoying. So usually what I do, I just go here to 3D icons. You could turn everything on a very detailed level on and off, but I just make these icons so small that I can't see them, and then I'm not hindered in the scene. For testing, just press here on play, and you should see that the demonstration cell will start to simulate. So basically, the robot will pick up these turbines and load them into these machining centers. You've got here different views which you could take. For example, here a view with a view on all the buttons, and also the overall view. Okay, for the moment it's enough, and if you see that everything is working as expected, your installation should be basically fine. There are maybe two things you need to make sure. One thing is under Edit, Project Settings. Please make sure that here on second player, you should have the scripting backend as a standard mono. You can change it to IL2 CPP, but for a start, I recommend to use mono. And the API compatibility level should be set to net standard 2.1. Another thing what we examine is that here we don't have any kind of labels on the buttons, and that's because Text Mesh Pro is still missing in our project. For installing Text Mesh Pro, you could, for example, select one of these buttons. And if I open here in a button, this sticker, you will get this message that Text Mesh Pro is missing. Or here, also here console log, or here you will get the here it is under Window Text Mesh Pro. So Text Mesh Pro is also an asset from Unity, which is still missing for displaying advanced text features in the scene. And that's why I need to import here the Text Mesh Pro essential resources additionally to realvirtual into my project. So please select this. We'll get again this window because additional stuff is imported. The import. And now if we start our scene, you will see the sticker on the buttons. So Text Mesh Pro is installed. So now we are fine and everything is inside of our project, what we need for using realvirtual. So now let me give you first some basic hints and tips how to use Unity. So first of all, mouse navigation in scene view while you're not playing, as well as while you are in game mode, is with the middle mouse button you can zoom in and out. With the right mouse button you can rotate, and for panning you should press the middle mouse button and you can pan. In the scene mode, basically you don't have any way for navigation. In the game view, you don't have any view for navigation while you are not in play, because the game view is the preview of your digital twin or of your game. So while it's not playing, there's no function in, and if you start here with a simulation, you will get the same way of navigating within the game view. The navigation is part of our functions and it's included in this realvirtual standard prefab, which should be existing in each and every scene you do with realvirtual. So that's the game and scene view navigation. Usually my advice would be, because every time you push here on play, to take this game window and make it small here, because for editing and building up digital twins, you don't usually work in the game view. The scene view is enough. Another thing what you can do by selecting here realvirtual, there's this option here, hide info box, and if you click that to true, you won't get anymore this info box on the start of the simulation. Let's take a look at the demo model we'll use in this tutorial. It shows a small production line, a conveyor belt feeding the turbine parts into the cell by a robot which is picking the turbine parts and loading and unloading this machining center. Even though it's a simple setup, it already includes many important features of realvirtual I/O, like drives, kinematics, PLC and robot interfaces, as well as PLC signals. This means we can simulate how machines move, how signals are sent, and how everything works together, just like in a real factory. We can use it for virtual commissioning via connecting it with real robot or PLC systems for testing our automation logic. But it can be also used, like in this demonstration cell here, only for simulating, where everything, the PLC logic, the signals, everything is inside of the simulation model. It's a great starting point for learning how to build and test industrial simulations within Unity. So let's go through the model step by step. First important thing is, if you ever close this model, how to get it reopened again. Easiest way is to select here under Real Virtual Open Demo Scene. There are also additional demo scenes for more technical single examples, but the main demo is this demo scene here. You can find the scene also under Real Virtual Scenes, Demo Real Virtual, that's this main demo scene. So let's take a look into the details of the model. First of all, if you would like to hide this overlay menu here, via clicking into the scene and pushing F1, you will get the full view into the scene without this overlay buttons. Inside of the model, we have got the robot. And the robot is basically a connection of several axes. And on each and every of these robot axes, we are having drives. In this demo cell, there's no real robot controller connected, and even not the inverse kinematics running, because the inverse kinematics is just included in Real Virtual I/O Professional. Basically, we are having here a recording of the drive positions. And the recording is started by signals. We'll come later to signals. So the robot is started in the loading and unloading process via signals. Besides the robot, we are having this demo cell, including the conveyors, for example. So selecting here conveyors. Let's start it again. We are having conveyors, and the conveyors are having also drives on them, and the drives are moving transport surfaces. So the transport surface, which is the conveyor belt, is moved by the drive. The drive itself is a generic component moving things. It could be a pneumatic or hydraulic or electrical drive. So anything which is moving something could be a drive. And the drive is, I would say, extended by a so-called, we call it behavior model. That's this drive simple, for example. These behavior models are giving us the detailed behavior in means of signal behavior of the drives. And for example, this simple drive has several PLC IOs. And here for the conveyor, it's just the IO entry conveyor start, which is starting the conveyor. If it's true, the drive will start. All signals are usually, if you are using it for virtual commissioning, underneath a PLC interface. In this example, it's an S7 interface. It's deactivated for the demonstrations cell because we assume that you don't have a ready-to-run Siemens PLC on your table. But if you have got it, you could connect it. So basically, under a PLC interface, we are having several signals of different types. Usually on all our signals, for example, Siemens, you need to import the symbol table. On Beckhoff, for example, you can import the signals directly from the PLC interface. So usually you don't need to manually set up the signals. You can import it from a table or via the interface itself. because we are not really having here a real PLC connected, there's a so-called simulated PLC in our demonstration setup. That's the main code controlling all this cell. And as you can see, all the signals are connected to my simulated PLC code. And it's like on a real PLC, basically we are having to this PLC code connected all our input outputs, which we need to drive this model. Besides of this, let's open the game view here again. Besides of our PLC and the robot and the machining center, we are having in here some buttons, yeah, and you can push these buttons and interact with the PLC state. For example, we turned here the automatic mode off, so after one loading sequence it should turn again, so you can interact with the PLC by pushing on these buttons. The buttons are here, so we are having in here all the buttons. And these buttons are also connected to signals, and via the signals, again, they are connected to the PLC. On the cell itself, so on the machining center, for example, we are having also some drives. For example, here for... it's stopped because I'm stopping, but we are... Let's go to the button again to select automated mode back again. So on the machining center itself, we are having also some drives. For example, a drive for opening and closing the door. And this drive here has a cylinder behavior model. So we are just having one signal. It's a 1-bit cylinder. So with 1 bit open door, true, we are opening it. And if it's false, so currently it's true, if the value is getting to false, the door will close. So also in our machining center, we are having some drives for this movement of the machine itself. So that's it for the moment. As a short introduction to realvirtual I/O and Unity, how to develop digital twins, how to install everything, and a first quick introduction into our demonstration cell for understanding the basics of realvirtual I/O. Thanks a lot for your attention, and please subscribe our YouTube channel. Thanks a lot. Bye-bye.